Algebra students, what is going on? We are here for another lesson, so I hope you printed out how quadratic equations in standard form can be written into vertex form. So the last lesson we talked about the three forms that we use with quadratics. Standard, we're going to talk quickly again about factored form, otherwise known as intercepts form, and then lastly we're going to talk to you about vertex form and how to get that into that form. All right, so let's do this one. So this is a recap of last lesson. So these are already in vertex form. So if you remember how to do this, great time to pause the video. Try to identify the vertex, the axis of symmetry, and whether it opens up or down. All right, and then press play and we'll go through the do now. All right. So the vertex can be found by taking the opposite of the number inside, because the original formula is minus h. So if it's, minus a negative, it would be a plus sign. So this is just minus positive 5. And then minus 1, whatever it is on the outside, you just bring down. So this is the vertex, just to give you a visual of what this looks like. If we go over to 5, negative 1, let's say it's somewhere around here. This is the minimum point, right? I know this thing opens up because the leading coefficient is 1, which is positive, so it's going to open up like a big U. So it's going to kind of come up here on this side and on this side. So that's kind of a quick basic sketch of our parabola. And the axis of symmetry is the imaginary line that cuts the parabola into two symmetric halves. The axis of symmetry always passes through the vertex. So this is an x equals equation, so it's going to go through x equals 5. Next, our vertex is positive 6, positive 2. Axis of symmetry is x equals 6. It's always x equals the x value, as long as our parabola is in standard kind of up or down form. And then we're going to open down, because there's a negative 1 is our a value. Remember, there's an imaginary 1 in front of that negative sign, or behind that negative sign, I should say. So this quick sketch is at 6, 2, so we're somewhere here, and it's going to open down. Axis of symmetry would be this kind of vertical line here. All right, that's the do now. All right, so vertex form. This is our newest form of a quadratic, so let's take a few minutes today and talk about this. But before we do, we're going to talk about factored and why factored is not always helpful. So before we do that, let's get into this. This is our standard factored form. F of x, remember that's the same as y, equals a. A is some constant value. It could be positive or negative. X minus h squared. The reason we need the x to be squared is because it's a quadratic, and then plus k is going to be the other point to our vertex, the y value of our vertex. All right, take a look at this picture here. Number 1, let's look at the graph to the right. The x-intercepts are where? Well, I got an x-intercept at negative 2, and I have an x-intercept at positive 1. So that means if I knew the equation of this parabola and I set it equal to 0, I would be able to factor it. How do I know I can factor it? Because the x-intercepts, or the zeros, or the roots, or the solutions are integers. They're actually rational numbers, so it's factorable. So we're going to have x equals negative 2 and x equals positive 1. Now, once I know the roots, I can write it in factored form. Some people refer to it as intercepts form. And again, it would be x plus 2 would be my first factor, because if I set this to 0, I'd get negative 2. And x minus 1, if I set this one to 0, I would get positive 1. So this is in factored form. Now, you could double distribute and get x squared minus x plus 2x is plus x minus 2. And you could put it in standard form if you wanted to, but it's not totally necessary, so don't worry about doing that. Right? Now, here's the problem. We cannot assume that the value of a is always 1 because it's not always 1. So here's what we're going to do. We are going to determine the factor a by using one other point. Okay, so let's take it like this. So I have y equals a times x plus 2 times x minus 1. Now here we were based on the assumption that the value of a is 1. But again, we cannot always just assume that. Unless you're told to assume it's 1 or you're given the value of a, we need to teach you quickly how to find the value of a. Okay, remember the value of a is going to make it more wide or more narrow, and it's also going to tell you if it's opening up or down, right? So here's what we do. Choose any other point. Now this one, I don't exactly know what that is. It looks like it's negative 3, 8, but I don't want to guess. So I'm just going to choose the y-intercept. I know it passes through 0, negative 4, meaning this is an x and this is a y. So if I substitute negative 4 in for y, again, I don't know what a is, so let's leave that alone. And then I substitute in 0 for x. I'm going to get negative 4 equals a times 2 times negative 1. That looks better to be negative 2a. And if I divide out the negative 2, I get a equals 2. So what do I notice? I notice that this equation is actually wrong. This is not that equation. The real equation is y equals 2 times x plus 2 times x minus 1. So this is actually a little bit more narrow than if it were this one. And again, another way you could check is plug this into your table of values, into your calculator, go to your table of values and see if 0, negative 4 is there. See if negative 1, negative 5 is there. It looks, actually, we can't assume that that's negative 1, negative 5, but I can see that 0, negative 4 is the y-intercept, right? And again, I could go ahead and put this into standard form if I wanted to. It would be the same as this, but with a 2 in front, and then you distribute the 2. All right, let's turn the page. All right, let's try another one. Now, what's the problem here? What do you notice this root is and this root is? Well, this is some decimal in between 0 and negative 1, and this is a decimal in between 2 and 3. So we don't know if these are rational or irrational numbers. So I cannot use factored form. But what I can see is the vertex is 1, 3. Now, that's important because 1, 3 is the vertex. So now maybe I don't use factored form. Maybe I use vertex form. But in order to find the value of a, I need another location. Now, we could choose 2, 2. We could choose 3, negative 1. We could choose negative 1, negative 1. Or what I always like to choose is the y-intercept 0, 2. If you can see the y-intercept. And if the y-intercept's also at an integer location. You don't want to guess if it's a decimal. Okay? All right. It does not appear that the root zeros of this parabola cross the x-axis at integer values. So we will not be able to write the equation in factored form. However, we can write it in vertex form. All right? So the first thing is vertex form is going to be a times x minus 1 squared plus 3. Where did those two values come from? That's the vertex. Now, I don't want to assume the value of a is 1 here, so I'm going to take the other point and I'm going to plug it in. So the value of y is 2. The value of a is unknown. X is 0. And then I'm going to solve for the only unknown variable, a. So this is going to be 2 equals a times negative 1 squared plus 3. Negative 1 squared is just 1, so this is 2 equals a plus 3. And if I subtract the 3 on both sides, I get a equals negative 1. So my final equation is negative x minus 1 squared plus 3. Now, how did I know the value of a was going to be negative just by looking at the picture? I knew because it's opening down. It has a maximum vertex point. So I knew that I was going to end up with a negative. So if you ended up with a positive here some way, you know you'd be wrong. All right, reminder. The zeros obtained from the x-intercepts of a graph can determine the equation of a family of graphs, but one more point is needed to guarantee a specific individual function's equation. This is not good enough. You need to choose one other point, plug it in, and get that value. All right, do a quick matching game. Do me a favor and pause the video. See if you can match these quadratics, which, by the way, are in what form? They're all in vertex form. Try to match it to these pictures. Pause the video, press play when you're ready. All right, so this vertex is -3, -1. This has a vertex of -1, 2. This has a vertex of -1, 2. This has a vertex of -3, -1. And this has a vertex of +3, -1. So the only logical choice for this one is this 5 right here. So this is A. It's the only one with a vertex at -3, -1. So we're done with that guy. Now the only vertex with 3, -1 is D. So that's not too hard. So you can see how vertex form kind of helped us match an equation there. What's the problem though? These two have the same vertex, which they do, -1, 2. They both go at -1, 2. But one of them is more skinny and the other one is wider. So here's what we want to do. We want to compare the number in front. Now, unfortunately, they both open down. So they're both negative, so that doesn't help us eliminate a choice. So what I need to know is that if this is greater than 1, it actually gets more narrow. And if it's a fraction less than 1, it actually gets more wide. You could do that a couple ways. Number one, you could just kind of memorize that principle. Or number two, you could plug these into your calculator and get a picture of skinny versus wide. Or lastly, you could take a point such as -0, -2 and plug it in and see which one it works in. And so this skinnier one is going to be for this one. And then B would be this middle guy. All right, I hope that made sense. We're going to do one last thing today. All right, last one. This is a procedure where we're going to use it by completing the square. Now, if you don't know how to complete the square, now is a very crucial time to go back to the distance learning video on completing the square. Actually, I don't think we have a distance learning one on completing the square. I think we did that in school before we left. But anyways, you can go on the website and check out that note and see if you can understand that before you try to watch this. So really important that you understand the process of completing the square before we do this. Now, what form are these in? These are all in what we would call standard quadratic form. Okay? Now, what if I wanted to convert this to vertex form? Here's what we're going to do. I'm going to teach you how to do one, and then I want you to try the other three. All right. You are going to take the first two terms, x squared plus 2x. You are going to add some number, and then you'll write the -4, and then you are going to subtract that number. Now, I'll explain why we do this in a second, okay? So my big question is, what is the magic number? Well, we have to go back to completing the square. We say half it, square it, share it. So we are going to take half of this term, 2 over 2. We are going to square that value. Now, 1 squared is just 1. Now, we usually share it on both sides of the complete the square process, but this one's a little different. If I'm going to take this equation and add a random 1, what is the only logical thing I can do in order to keep this the same as the original? The only logical thing I can do is if I'm going to add 1, I must also subtract 1. So these two things cancel each other out, and guess what you're left with? You're left with this original thing. Remember, math is all about what am I allowed to do and not allowed to do. If I want to add a random 1, I can do it as long as I offset it by subtracting a 1. Now you might say, what was the point of that? Here's the point. We just completed the square with this trinomial. So this trinomial factors to be x plus 1 times x plus 1. You could do that AM method here. Add, multiply. And since it's x plus 1 times x plus 1, just like in completing the square, we do x plus 1 squared. And then these guys are going to give me minus 5. Now, what do you notice? Here's what we notice. This is now in vertex form. The vertex is -1, comma, -5. And we're done. So if that made sense to you, go ahead and pause the video, try these next 3. If it did not make sense to you, watch one more and then pause the video. So here's what I want to do here. X squared plus 16x plus something, and then plus 71 minus that same thing. So half of 16 is 8, and 8 squared is 64. So I want to add and subtract 64. Now this is going to factor out very nicely. What multiplies with 64 and adds to 16? 8. So x plus 8, and there's going to be 2 of them, so we square it. And then 71 take away 64 is going to be 7, so that's plus 7. So my vertex is -8, comma, 7. All right, if you get it by now, pause the video, try the next 2, replay it, and then attempt to follow the video and see if you get it right. All right, here we go. X squared minus 2x plus something minus 5 minus something. Half of 2 is 1, 1 squared is 1, so I'm going to add and subtract 1. This is going to factor to be x minus 1 squared minus 6. Again, these give me minus 6. This factors very nicely. It's called completing the square. And my vertex is as follows: +1, -6. And the last one is y equals x squared minus 12x plus something plus 46 minus something. Half of 12 is 6. 6 squared is 36, so that's my magic number. I'm going to add and subtract it so that essentially nothing is happening. And now I'm going to take x minus 6. I'm going to square it. 46 minus 36 is going to give me a 10. We are now in vertex form, so my vertex is 610. And that is that. Now notice, we only did examples today where the a value was 1. The value of a, remember, standard form is ax squared. So all of these had an a value of 1. This process gets slightly more complicated. We're going to do that in a later video on what happens when the a value is not 1. And that's going to kind of complicate this just a little bit. One extra step, but not too bad. But first, before we go there, see if you can just master this and do that. Last thing, shown below. You have f of x and you have g of x, 2 different quadratic functions. How do I know these are quadratic? I have x squared and I have a parabola, so I know these are quadratic functions. Which has a larger maximum? Well, the maximum here is 5, 8. And the maximum here is 4, 5. So it appears as if this guy has the larger maximum. So we'll just kind of box that guy in. 5, 8 is higher than 4, 5. So that's the larger maximum there. All right, hopefully this video made sense and you have some time today to practice, do some castle learning questions. Also go on to the homework section and try the extra practice. Really important that you are practicing. Practice is absolutely essential for success, especially in math. So please be practicing, emailing questions. If you have them, comment below if you have any questions as well. All right, talk to you guys soon. Be well.